So to start with the project, we decided on a bike lock because I personally ride my bike to school every day. I've had my bike stolen from campus, and so a bike lock is super important. And so it's just very vital to have something that can secure your bike and be easy to use. Since it's getting colder and I'm usually late to class, I don't want to have to fumble with keys and waste time and get cold and stuff. And the key card design just makes it super easy and straightforward to use.
One of the main benefits of the RFID bike lock is instead of having to fumble for your keys and remember which pocket you put them in and make sure you have the right key and the orientation's right to get in the hole, and making sure that you're turning it right and taking the whole thing off and then putting the whole thing back on, you can forget about that and instead just use the RFID card that's in your wallet, scan just like that, and open the bike lock. So the components of the U-lock are pretty simple. We start here with an Arduino. The Arduino is attached to a power supply over here, and it's through the serial port here, so the Arduino is able to take as much power as it needs from the battery, so we don't have to worry about regulating power. Attached to the digital pins on the Arduino, we have this RFID reader that recognizes the card and sends the code to the Arduino. If the code matches what we have stored, it will unlock over here. Speaking of unlocking, we've got a servo over here. The servo is attached via a paper clip to this little metal pin that goes inside this 3D printed casing. The pin can slide back and forth and is locked on either end by these two supports. To relock, we've got this bar, which serves as the lock, that will go up and hit a limit switch. And when the limit switch is contacted, the servo moves the pin towards the locked position where you can no longer move this out. Once you want to unlock it, you scan your card again, the pin moves out, and the bar can fall down. The bar is attached via a bearing and a zip tie for the prototype onto the other side of the U-lock so that it can rotate freely and come into contact when needed. So in terms of testing, our couple main tests were making sure that the servo was calibrated correctly so that it was going back and forth the distance that it needed to go instead of breaking itself when it went too far backwards. So that took a little bit of testing just to narrow down those parameters. It took about an hour of testing to get this hinge correct. When we ended up using the bearing, there were a couple prototypes before that using nuts and bolts to just kind of tighten everything, and in the end the bearing with the little foam around it ended up working the best. And the final test that we ran was a current draw test to just see how much power this thing was actually taking. That's how we determined that we couldn't use the 9-volt battery. So that's why we ended up going out and getting this rechargeable USB battery, which added the functionality of being rechargeable to our final product.
Because it plugs right into the part of the Arduino that plugs into the computer, the Arduino automatically draws as much power as it needs, and we don't have to worry about regulating the power because it's there doing it for us.
Because of time and resource restrictions, we weren't able to make what we would consider a fully production lock. What we have made is strictly a prototype.
So, for example, this 3D printed casing right here, we would ideally be instead made out of metal. The exposed wires would not be there. They would all be part of the lock's casing. Also, this metal piece would be surrounded in the rubber that encases the other part of the original lock, as well as, instead of a taped battery to the side, it would be integrated into the casing. There wouldn't be any sort of zip ties or plastic that could be damaged, with just a hammer or something like that to try to get into the lock. So a fully defined end product would ideally just be made of metal and the rubber encasing. That way it would be less likely to be physically damaged and broken into that way.
We originally wanted to have a stepper motor hinge the locking bar so that you could unlock the bar, leave it against the bike, and it would auto lock itself. But because of power restrictions, we unfortunately weren't able to do that.
Originally, we thought of using a solenoid lock as our locking mechanism. Because of power constraints as well, it took 12 volts. We found a way around that. One last original concept that we didn't end up following through with was an NFC reader instead of the RFID. NFC would have allowed you to use your phone, which was a big component of one of my stakeholders' requests. However, NFC wasn't very compatible with Arduino, and because of the time constraints, we weren't able to make that work. Instead, it was the RFID, and that is still just as good.